Okay, in this video, we're doing Calc AB problem set 42. The problems and a playlist are in the description below. Hopefully you've done the previous 41. I doubt it, but you never know. Maybe somebody's out there doing all these. Let's take a look. Use the graph. There's actually only one question for this. It's just there's a lot of parts, so I broke them up into separate kind of pages. Use the graph of f shown above to answer the questions that follow. A, based on the graph, on what intervals is f of x concave down? So we're talking about the actual graph we're looking at. Very unusual. But, you know, concave down there. So I'm going to say that f of x is concave down on 0 to 4 and also 9 to 12. And I'm not even giving a reason there because, that's where it's concave down. I don't know. All right, next up. Given that g prime is equal to f of x, where is g of x concave down? All right, so now we're looking at the graph of the derivative. So if we're looking for concave down, what we really need to happen is we need g prime to be decreasing. You look at the graph and you're like, this thing is decreasing here. So now we can write our answer. I'm going to say g of x is concave down on 2 to 6 because g prime, which is equal to f of x. I always worry that people are not going to know if I just write g prime. And it's weird if you just write f of x. So I usually write g prime equals f of x, is decreasing there. That's all you need. Next up, this is like a reading a derivative type of question. I love these. Given that h double prime is equal to f of x, so now we're looking at the graph of the second derivative. Where is h of x concave down? Looking at the graph of the second derivative, we need the second derivative to be negative for a function to be concave down. So negative means below the axis, so kind of on this interval. So that looks like 4 to 9. So I will say h of x is concave down. Concave down. That sounded really weird in my head when I said it. On 4 to 9 because h double prime, which equals f of x, is less than 0 there. I think that's a totally good answer. Next question. This is a pretty quick one because it's just reading this graph. Given that g prime is f of x, so now we're looking at the graph of the derivative again. Find and classify the critical points of g of x. Okay, so to find the critical points, that's where the derivative is 0 or undefined. The derivative is never undefined. So at 4 and at 9, those are our critical points. So let's write that down. G of x has critical points, which I used to abbreviate as CP, and then I decided I didn't really like that. Like my older videos, you'll see that. I have decided you should abbreviate critical points as crit pits. So CRIT, PTS. I think you will always be fine there. I don't know if CP is generally accepted enough. That's why I kind of changed my mind. But anyway, critical points at 4 and 9. Now we need to classify them, right? So at 4, you can see that f prime is going from positive to negative, which means f is going from increasing to decreasing. That's a relative maximum, so let's write that down. G of x has relative maximum at x equals 4 because g prime changes positive to negative there. Notice I didn't say g prime equals f of x. I just got tired of doing it. I don't know. Usually you don't answer so many questions at the same time about the same topic, so it's a little easier to go in with those sorts of things. Anyway, that's my explanation. At 9, you can see that your derivative is going from negative to positive. When you go from negative to positive, that means that the function itself is going from decreasing to increasing. You're at a relative minimum. So let's write that down. G of x has a relative minimum at x equals 9 because g prime changes negative to positive there. All right, let's take a look at the last part of this. This is a very quick one, this whole problem set, I think. If you know what you're doing. If you don't know what you're doing, it just takes a little practice and you will be just as fast. Given g prime is equal to f of x, find the x-coordinates of the points of inflection. By the way, it's definitely the x-coordinates. Don't even think about trying to find the y-coordinates. We do not have enough information to do that. You almost never ask for the actual point of inflection. You're almost exclusively asked for the x-coordinates. We want the x-coordinates of the points of inflection, and we want to justify it. All right, so that's going to be the relative extrema of the derivative, so at 2 and at 6. And my reasoning is going to be because g prime equals f of x has relative extrema. So let's write that down. G of x has point of inflection at x equals 2 and x equals 6 because g prime equals f of x has relative extrema there, or at those points, or at those values, however you want to say it. Anyway, that's actually the entire problem set. I hope you found this helpful, and good luck.